Hi, my name is Shalini De Mello, and I'm a principal research scientist in the Learning and Perception Research Group at NVIDIA. I'm really excited today to share with you this tutorial that my colleagues and I have created on the new frontiers for learning with limited labels or data, in conjunction with the ECCV 2020 conference. While we made tremendous progress in computer vision and AI in the past 10 years, in the words of Jan LeCun, the AI revolution will not be supervised. So why should we care about learning with limited labels or data? Well, large data collection and annotation efforts are very costly and they're just not sustainable for the long-term future of AI. After a certain point, data collection hits the point of diminishing returns, and data that is redundant or has previously been seen doesn't seem to improve the performance of AI systems any longer unless they're from the long tail of the distribution. Having to collect large amounts of data and annotate them also prevents AI from being democratized among societies or cultures that cannot undergo such costly efforts. And as a researcher, there's always this curious question of while humans and even babies and children can learn from imperfect and little data, why is it that we're not able to train AI systems to be able to do the same? Well, the good news is researchers have obviously been curious in this particular area, and there have been many techniques developed, particularly with deep neural networks for semi-supervised and weakly supervised learning, for zero-shot, few-shot, and one-shot learning, continual learning, learning from other modalities, or of generative modeling of data. To go beyond the topics that have been widely explored in the literature of learning with limited labels or data, in this tutorial, we're going to explore some emerging new exciting frontiers to, to push the boundaries of this task even further. The first topic that we're going to explore is on self-supervised learning, and we're going to have two talks describing how self-supervised learning in computer vision can be successfully used to learn parts and viewpoints from image collections that are not annotated, as well as ideas for learning in a self-supervised manner correspondences across instances and video frames that can be used to solve various different computer vision tasks. The next set of two talks will pertain to learning with imperfect labels, notably noisy labels using the contrastive noise formulation, as well as unifying frameworks that are able to learn across different levels of supervision, ranging from fully supervised to completely unsupervised. And the last set of talks explore a bold new topic of inverting neural networks to hallucinate data or to provide feedback which is inspired by biology or biological neurons in order to train neural networks with less data or with less labels and be more efficient. You can also check out the PDFs of all our talks from our tutorial website or the pre-recorded videos from our YouTube playlist. And we'd also be happy to take questions from you. You can contact us via Twitter, for example. And with that, I'd like to thank you for your attention, and I hope you enjoy the rest of this tutorial.